data centers purely in active mode. You need to ensure that both the data centers should be in range of 100 kilometer. Latency should not be beyond 5 milliseconds. If you are leveraging the fault tolerance, then fault tolerance has a limitation that the latency should not be 1 millisecond. So make sure that if you're leveraging a fault tolerance and if you are going with the active multi-site clustering architecture, then latency should not go beyond 1 millisecond. In the multi-site cluster, both the storage are always in read-write mode. They are actually doing the block level synchronous replication across both the storage. Okay, coming to the storage virtualization, so just like server virtualization, we will quickly talk around how storage virtualization ecosystems helps in addressing critical non-functional requirements like data protection, recoverability, and data retention. So what is storage virtualization, and what are the benefits that we generally get from the storage virtualization? So abstraction or isolating of physical storage functionality from application services is nothing but storage virtualization. Or in other word, or in simpler word, it's a pooling of physical storage from multiple network storage devices into a single storage devices that is managed from a centralized console. So a storage virtualization is not a new, I think not a new feature. If I recall it, I think some sort of storage virtualization has been running since mainframe era, like your LVM and RAID are again nothing but some sort of storage virtualization. So in terms of the benefit that we generally get out from the storage virtualization, so with single logical unit, it actually isolated the storage services from the applications, which essentially means that application will never come to know from which storage data is being served. It simplified the enterprise data management through a single console, and hence it minimized the overhead for the storage admin. Earlier, any old storage that has to be phased out or let's say needs to be upgraded would always require a lot of planning, downtime, and operational cost to migrate the data from one storage to a new storage. But with storage virtualization, data can be migrated in non-disruptive manner with a very, very less time. We can now club old storage and new storage and using storage tiering features to actually allocate application resources to appropriate tier. Example, mission critical application can be deployed, let's say on tier 1 using SSD drive. Less critical application can be deployed in tier 2 using SAS drive. Application which are non-critical are for the development mode, or if data has to be backed up, I think these sort of data can be pushed into the tier 3 or the SATA-based storage systems. So with features like auto tiering, with single management console, and overall consolidation of storage, primarily helps in reducing the total cost of ownership using the storage virtualization. The other benefit that we get out of the storage virtualization is that essentially all storage block level applications are vendor agnostic. That's how the current storage vendor model is. But with the help of storage virtualization, it actually supports the heterogeneous applications. Hence, data centers can be replicated across 2 storage vendors. So that is really one of the great features that actually come up with the storage virtualization. Data protection, the key feature here is that I think before we actually deep dive into the data protection, we'll try to understand what the data protection is. It's nothing but the ability of the system to protect the data in case of the system failures. Storage snapshot is very good feature when it comes to instant backup and the restorations requirement. So it's nothing but a point-in-time backup copy of storage. So these features help in storage data replication across multiple data centers where only block level changes get replicated, thus reduces the overall bandwidth required for the application. The only downside of the con with the snapshot is that if you really want to revert back to old snapshot, so all changes will be reverted that had been taken between last snapshot and the current state, which means that you cannot restore file or folder level backup in this case. So essentially, this storage snapshot is not a pure standalone backup solution. Rather, I would say that it's more like a catalyst for a system to provide you data protection. So there are multiple ways of creating a snapshot. Example, you can go with copy on write. Within a storage, there's generally when you configure storage, you actually reserve some sort of snapshot area into the storage. When you enable a feature called copy on write, any changes in the existing block which is first copied into the snapshot area before the block get overwritten or get modified. The other way of doing the snapshot is more around the redirect on write, where the block is redirected directly to snapshot area so that the latest copy or latest changes on the blocks are written to the snapshot area rather than the actual area. The other way of doing it, like split mirror through the log file as well. But what I will say is that I'll quickly try to cover write and copy method. How does it work? So
Narendra, are you able to hear me? Your voice is not audible. Can you please check? Hello? Narendra, are you able to hear me? Narendra, you are not audible to the audience. Can you please check your audio settings? Narendra, you are not audible to the audience. Please respond. Narendra is trying to reconnect with us. Please have patience. He would again resume the presentation soon. Hello, Narendra. Are you able to hear me?
Hello. I can. Am I not audible to you guys? I think I got disconnected somehow. I don't know how, but.
Yes, you did. You did. Please continue with the session.
Can you tell me where I was? Was it really help me to understand so that I can connect from that session itself.
Yes. So you can start with the fresh slide because the second point you missed out. So you can start fresh with this slide.
Okay, cool. Thank you. Sorry guys, I was somehow disconnected. Anyways, going to the session again. Just refresh what I've been speaking out. I'll just quickly go through the event sequence, how the snapshot mechanism works. As I said that when the storage is configured, storage admin generally reserve some sort of data and make it as a snapshot reserve area. It's generally between 15 to 20% of your total data space of your storage. This particular area is where the change in data or the delta data has been pushed when you keep the snapshot over the period of time. When the snapshot is created, it primarily takes a logical copy of the data. Once it actually shows your application for a very short period of time. Let's say if a write request comes from a system and it has to modify the existing block, then in that case, the first step is to the existing data from the same block is first returned to the snapshot area, and then the data gets modified into the actual data space. A read into the logical copy is redirected to original copy. So if in case the data is not been modified, all the read requests will actually coming from your actual data space. If in case a read request which is coming for the modified data, then in that case the request will actually go into your snapshot area and fetch that data. And that's how the snapshot mechanism works.